A simple pendulum is of length L, but there is a peak at a distance L by 2 below the point of suspension. Find the time period of such pendulum. Okay, so a simple pendulum, L is a simple pendulum and L by 2 is peak. L by 2 peak and L is simple pendulum. Okay, now we have to find the time period, both peak and simple pendulum. Okay, L simple pendulum and time period of simple pendulum and time period of peak. So we know that time period of simple pendulum, time period of simple, okay, pendulum. So time period is taken as t. So time period equal to 2 pi, okay, 2 pi L by G, okay, 2 pi L by G. And now total time period of this given diagram, total time period equal to T means total time period by 2 plus, so time period of pendulum, so simple pendulum T1 by 2 plus time period T2 by 2, okay, this one T2 means time period of peak, okay, so the total time period equal to, so T1 by 2 plus T2 by 2. So using this formula, now T1 is equal to how much? So equal to taking half common, T1 plus T2, okay. Now 1 by 2, half 1 by 2, the time period of T1 means time period of pendulum is 2 pi L by G root over 2 pi L by G root over taking, okay, plus 2 pi, here L is equal to L by 2, but here L equal to L by 2, L by 2, L by 2, L by 2 divided by G of root over, okay, root over. So equal to 1 by 2, now 2 pi taking common, okay, so L by G root over plus L by 2G root over, okay, L by 2G root over. So equal to 2 will cancel, so phi L by G root, okay, plus this one also written as L by G root into 1 by root 2, okay, 1 by root 2. So equal to, now common, pi L by G root, taking common, 1 plus 1 by root 2. So this is the time period, okay. Our question is find the time period of such pendulum. So time period of such pendulum is phi, okay, the phi whole of L by G of root over whole 1 plus 1 by root 2, okay,